Assalamu alaikum wa rahmatullahi wa barakatuh. My name is Zaid Ali Hamid, and this is my project. It's depression detection via voice using convolutional neural network (CNN) and null frequency substrate coefficient (MFCC). Our content contains of background, research problem, aim and objectives, scope of work, literature review, methodology, results, conclusion, and references. Depression disorder. Huge number shows that mental disorder are the main cause of poor health condition and disability worldwide. Depression disorder are in the place of second leading which cause disease burden by 2020. Depression disorder effects. One of the dangerous effects of depression disorder is converting the person to be a hurting individual to themselves or to others by taking suicide or crime against others. It is important to have an early detection of depression system that would help the doctors to identify people who have earlier signs of illness. Automatic depression detection. The automatic depression detection method focus on two major categories, machine learning and deep learning techniques. Deep learning techniques can found to be high-level semantic extracting than machine learning. Problem statement. We have challenges in our research. The first problem is to design a model using existing computer AI algorithm such as machine learning and deep learning methods to provide a high quality dataset. The second problem is how to extract and determine the most feature in several complex audio feature using artificial intelligence algorithms. The third problem is to build high efficient detection model which give a high accuracy of prediction. CNN is generally used in training dataset. However, the method used has a few training set and less emotional information. Hence, MFCC is used to extract the audio features and assess the training dataset. In this approach, the CNN is not involved in the training dataset. Therefore, to combine both MFCC features with CNN model is a challenging issue. To solve this problem, the extracting audio features from the CNN model was not performing to the accuracy we expected as it was giving above. We therefore decided to use MFCC features, which were able to extract important features for learning. These MFCC features were then transferred to the neural network model so that even though the features were not CNN. Aim and objectives. The main aim of our project is to build a model that can accurately predict depression disorder from an audio files that would benefit the counselor and the psychologist at the earlier stage of treatment. And we have two sub-objectives. The first objective is to build an automatic depression detection model on audio file using deep learning based on convolutional neural network with high accuracy of prediction more than 80%. The second objective is to extract the most feature of the individual speech using null frequency substrate coefficient method that would benefit the classification of the model toward depression detection. Scope of work. This work motivates by the guideline provided in 2016 Audio-Visual Emotion Challenge. These guidelines defined in the form of depression classification sub-challenge. The main goal of the guideline is to find if an individual has diagnosed with depression disorder illness or not by using text, video, image, and audio data. In specific, this work only focuses on audio files and information provided. For this matter, the proposed model is built on speech information classifiers based on convolutional neural network. The audio features are extracted using null frequency substrate coefficient method. The database is obtained from Pearson audio-visual database of emotional speech and so on for the evaluation of the model. And literature review. Here, as we can see, there are many authors that worked in the same field of depression detection that they used different data type for their work on different methods. Different data type is like, as we can see, they used data from social media, from Twitter as example, and health record, the questionnaire, video data, robot interaction, and audio. The method they are used is machine learning with text mining, supervised machine learning, semi-supervised, class bridge based technique, supervised 5-layer machine learning, and other methods they used. And they all want the target of their work is to detect depression or to improve the understanding of mental illness or earlier detection or improve the accuracy of their model or detect the best scenario for the model and so on. Here's methodology. This is the general block diagram of the proposed model. As we can see, the audio samples we have from the dataset we already have and from the computer microphone will first go to a pre-treatment, which means pre-process. And after that, we'll go to the front end, which contains of the MFCC features, the features extraction of MFCC with short-term energy and entropy of spectrogram. These are features used with MFCC on audio files. And after that, it will go to the back end to the CNN model to do the classification and lining of the data we have. Here is the specific process of the proposed framework model using CNN and MFCC. First, as we said before, it will go to the pre-processing, in the pre-processing stage, it trims the audio into continuous segments, as well as deionizing the data and remove the noise if it's available there. The next step is the model. The next step in the model is the feature extraction using MFCC and entropy of the spectrogram and short-term energy. Here, the feature of the audio samples are fetched to extract important features that are able to explain the audio better. Then the extracted feature of the audio samples are fed into the depression framework provided by Python. This step ensures the training, identifying, and the classification of the depression. Then it will the MFCC training will separate the data we have for two sets, training sets and test sets. The training sets after that will go to the CNN model to do the training there and to be classified and lined as on the model on CNN. After that, it will do the prediction model. And after that, it will test the accuracy of the model, depend on the prediction we already have. Like that. So the data set is collected from Rarson audio-visual database of emotional speech. The dataset contains a wide range of audio from clinical interviews and persons' voice records that supports the diagnosis of depression, anxiety, and post-traumatic stress. The dataset collected with 1,500 audio samples. Each sample represents an individual speech with session ranging between 2 to 5 minutes. In the same time, a live audios recording taken from 15 individuals are also collected using microphone. The score of 1 and 0 is split for the non-depression and depression respectively. To obtain the required audio features, a pre-processing is done on the audio dataset, as we said before, obtained from the Rarson database. After labeled from PHQ-8, labeled for this PHQ, it's labeled the data as depressed data or non-depressed. The audio recording found to have silent segments with a few seconds, following by dividing each audio into the same length of the original audio recording. Then Hamming window technique is used for framing the audio recording, with each frame has 1,024 data points. The sampling audio rate is 32 kilohertz. Hence, the audio recording has a time covering of, depends on this equation, the formula equation we have. And here, as we can see in the pre-processing stage, this is a sample of audio wavelet representation with 32 kilohertz. And after that sample, it's the same sample wavelet representation, and we add the with the low pass filter. So to prevent the aliasing between the aliasing and we'll do the noise cancellation with the wave signal. Audio extraction using mel frequency substrate coefficient. The resulting formulation clarifies how to convert the common frequency domain scale of audio to MFCC frequency scale. And here, as we can see, voice sound wave signals for normal and depressed person. We will be extracting MFCC features as opposed to CNN features, as previous studies have shown that MFCC features capture more important aspects of audio files compared to CNN features. A model using MFCC features also perform better. We therefore decide to use MFCC feature since they are able to extract important features, 26 features in total for each audio file. For learning, these MFCC features were then transferred to the neural network model, so that even though the extraction were not in CNN, but the learning and the training will be done using the CNN model. And here we can see a normal and depression sound wave signal for male and female. And as we can see, there is some uncertainty in the wave of normal person, which leads to a greater the great uncertainty we have will lead to greater entropy, and that will be different from male to female. Convolutional neural network classification of depression recognition used via Python. Here, as we can see, a Python codes for loading the required libraries for data preprocessing and reading and understanding data preprocessing pandas, and computing the missing value from the input data, converting text to integer, and targeting the depressed column. The mechanism that CNN is utilizing is that it plays a great role to in extracting features of the stored audios. And based on those extracted features, the MFCC will start doing its function by comparing the extracted features that CNN has done with the features that MFCC has done, in order to be able to make decision where that audio speech of certain person is depressed or non-depressed. And here's the results. Here, as we can see, it's a score of the training dataset using different values of filters for non-depressed and depressed. As we can see, when we use number of the value of filters is 32, it will work better in prediction, in depression prediction more than others, more than 20 and 40. And here, as we can see, we will use RMSE, root mean square error, which is it's a tool to present the root mean square of error between the true value and the predicted value. And also we will use mean absolute value. It is used to present the error between the true value and the predicted value. As we can see, our model, which is 32 filters, the performance of our model will be better than other filters. So here in this table, as we can see, this is the performance of our model, which is 32, in the score and precision and recall and accuracy, and it's better than the others. And here, as we do experimental results for different length of MFCC, which is ranging from 10 to 15, and different length with compared with RMSE and MAE evaluation. And as we can see, in all lengths of MFCC, when we take the filter number as 32, it will be the lowest of all others, which means the performance is better than the others. And here's the prediction result of the model with the accuracy. As we can see here, we have 37 true prediction for 37.33% as a true prediction, which is non-depressed, and only 10.44% it's false prediction. Then we have 42.67 for true negative, which means depressed, and 9.56% false predicted. And this is the accuracy of our model is 80%. The precision of the model is 78, and the recall is 79.62%. And here, these are the codes for audio signal capturing from the microphone. A sample of tested data set with prediction of depression disorder. And here's the 15 samples that we took from the microphone, and as we can see, the prediction was right with 9 samples and false with 6, due to the small numbers of samples. And here, as we can see, a comparison between the proposed model and the other models like LSTM, MTL, TMS, and MFCC in terms of MAE and RMSE and accuracy. And in all of them, it works better than the other models. This work introduced a depression detection model based on both MFCC extraction feature method and CNN techniques. The MFCC method used to extract an audio file features, then trained using CNN with filter machine of 32. The dataset is obtained from Raresen audio-visual database of emotional speech and song database with 1,500 samples, and the model randomly choose 1,265 samples for training the model, 235 samples for verification dataset, and 15 samples for test the model. The training dataset is evaluated with root mean square error and mean absolute error method as evolution indicators for error prediction. A 37.33, as we said before, percentage predicted data, which is non-depressed, is matched with the true value, while 10.44% is considered false. Similarly, with 42.67% of predicted data depressed, matched with the true data, while 9.56% having a false prediction. The accuracy achieved for the training model is 80%, with 78.14% precision and 79.62% for recall. Test dataset including 15 individuals with direct input for audio files from microphone speech. A total of 9 prediction was correct, with 6 prediction were not correct. For future work, we suggest including a design of a more complex layer in CNN to consider more information in multiple layers. This would help in the capability of featuring more information from audio files that gives more accurate predictions. Additionally, design a dynamic MFCC and CNN model during a pre-processing phase would benefit to extract more information from audio when it comes to misleading information that possibly obtained from the speaker, especially when individuals not mention themselves. And thank you so much.